For question 7c, we are told to evaluate cosine square pi over 6 minus tangent square pi over 4 over sine square pi over 3. Let me put it at the side. Sine square theta. This is how we read it. Sine square theta is equals to sine theta times sine theta. So we write it as sine theta square. We can write it like this, but the norm is to write it this way, okay, without the brackets. But you put a square on the top right hand corner of sine. That's all. Okay, so obviously we've got cosine square theta. Cosine square theta is simply cosine theta times cosine theta. Can you make a guess what does tangent cube theta refer to? Tangent theta times tangent theta times tangent theta. So tangent theta, the whole thing cube it. Okay? So with this, let us work on 7c. Cosine square pi over 6 is the same as cosine pi over 6. Whatever the value is, we square it. So what is cosine pi over 6? How much is cosine pi over 6? Huh? Cosine pi over 6. Come on. Root 3 over 2. Okay, so we've got root 3 over 2. And I have to square it. Then I minus tangent square pi over 4. How much is tangent pi over 4? Tangent pi over 4, oh yes, 1. Okay, so minus 1, and I square it, divided by sine square pi over 3. How much is sine pi over 3? Sine pi over 3, root 3 over 2. Over 2, and I square it. Okay? So this gives me 3 over 4 minus 1 over 3 over 4, which is 1 minus, what is this? Of course, you can use your calculator to evaluate this part. So that's 7c. 7d. It looks like it's, you might have a problem with the certs. Yes? No, watch the video. Cosine pi over 6 minus tangent pi over 4 divided by sine pi over 3 plus cosine pi over 3. Okay, first one, cosine pi over 6, how much is it? Square root 3 over 2 minus tangent pi over 4? 1 over sine pi over 3? 3 over 2 plus cosine pi over 3? I hope you can tell that I really didn't memorize these values, because it's not necessary. You can just get these values from a calculator. Okay? So first step, what would you like to do? You got a fraction inside a fraction. Everything multiplied by 2. Okay, so when you say everything multiplied by 2, you're referring to numerator multiplied by 2, denominator multiplied by 2. Don't forget the basics, otherwise you may end up with lots of careless mistakes that you don't expect yourself to make. So the first one multiplied by 2, we get root 3 minus 2 divided by root 3 plus 2. Now what? Huh? Plus 1? Oh, sorry. It's plus 1. Okay, so now, how do we proceed? Times root 3 minus 1. Why do you choose to multiply by root 3 minus 1? I assume you are referring to the bottom, root 3 minus 1. Is this it? Are they equal now? No, right? Because you multiply denominator by something. They are no longer equal unless you multiply the numerator by the same factor, root 3 minus 1. Okay? So now, denominator is easy. How much is it? A plus B, A minus B. Right? We've got A plus B, A minus B in the denominator, which is simply A squared minus B squared. And doing so will definitely result in a rational number. Okay, so root 3 squared is 3. 3 minus 1 is 2. Okay, that's the denominator. Numerator, we've got root 3 times root 3, that gives us 3. Root 3 times negative 1, negative root 3, minus 2 root 3, plus 1. So this gives me 3 plus 1, 4 minus 3 root 3. Huh? Yeah, sorry. Plus 2. Thank you. So 3 plus 2 is 5. N over 2. Can? This is the final answer. Yes? You didn't multiply by 2. So what do you do? Also can. You will get the same answer. Yes. Okay, next question we have is 8H. For question 8, you are supposed to find basic angle, am I right? Okay. The diagram is as such. We go one round until here. And this is, how much is this angle? Negative 3? 2 over 3 pi, is that it? Okay, so the basic angle is found here, alpha. And that's what I need to find out. So let's follow the rotation. Can I check for one complete cycle, how many radians would that be? 2 what? Not 2 radian, 2 pi radian. Because pi radian is the same as 180 degrees. So one full cycle will be 2 pi. That is the magnitude of the angle, okay? If you go clockwise, it will be negative 2 pi. You go anti-clockwise, it will be positive 2 pi. So we start from here, we went clockwise until this point. How many radians? 2 pi radians, isn't it? Okay, so we've got 2 pi radians already. Then from here, if you like, you can do mental sums, convert everything to degrees if you like, but there's really no need to. Okay, so this is 2 pi radian already. I add another half a circle. So until this point, how many radians so far? 3 pi. Then I add a quarter of a circle until this point. Okay, so until here we've got 3 pi already. Another 1/4, how much would that be? 3 pi. 3.5 pi lah, okay? Because just keep in mind, pi radian equals to 180 degrees. So 2 pi radian is 360 degrees. Pi over 2 radian is 90 degrees. So over here, just now we went one full cycle plus another half cycle. We've got 3 pi already. Now I want to continue with another 90 degrees, which is another pi over 2 radian. So until this point in time, we've got 3.5 pi already, magnitude-wise lah. Okay, the sign is just negative because we are going clockwise. Okay. Now from here to here, how much is it? Because total, according to the diagram, according to the question, is we've got 3 and 2/3 pi. So far until this point in time, we've got 3.5 already. Are you now able to find out the remaining angle yourself? Can, right? If you can find the remaining angle, you can also subtract to find alpha yourself. That is one way to do it. Yes? Yes, you can. Okay, that's one way to do it. That is the rather long way. The shorter way, I'm going to show it to you now. Give me a moment. I go one full cycle. That will be 2 pi, right? Then if I continue another complete cycle, how many pi would that be?
4 pi.
This is 4 pi. Or rather negative 4 pi lah. Okay? Then the question already gave us negative 3 and 2/3 pi. So if we subtract these two, wouldn't that give us the basic angle already? Then that's the easier way lah. But the first way forces you to think and keep on correlating your radians with your degrees. Okay? That's just for practice only. So in this case, the basic angle, which is alpha, is the same as 4 pi minus 3 and 2/3 pi. So we get 1/3 pi. Yes? Sub in the value, what do you mean? Pi radian.
This angle must be presented in volume.
Between 0 to 90 degrees, it must look like this. Okay, so this is theta. This is the first option. Then the second option is that it is from 180 to 270. So which quadrant would that be? 180 to 270. Quadrant number 3. So it has to look like this. This is my theta. Okay, these are the two options. First one, theta between 0 to 90 degrees. So they also tell us that the basic angle is 42 degrees. So basic angle, this being 42 degrees. And the basic angle in my third quadrant looks like this, 42 degrees. And they are asking me to find the value of theta. So in the first case, theta will simply be 42 degrees because it is exactly the same. Whereas in the second case, my theta starts from this point until this point. Okay? So we can break this down into two parts. First, along the x-axis, we've got 180 degrees. So I need to add another 42. So this will be or 180 degrees plus 42 degrees, which gives me 222 degrees. Okay, Cosby? So now for 9C. Oh, theta is from 0 to 360 degrees, which is one full cycle. So all four quadrants are possible. First quadrant, our theta will be over here with the value of alpha 65 degrees. Okay, so theta must be equal to 65 degrees. Then in the second quadrant, that's for the second quadrant. Third quadrant, theta 3. With the same basic angle of 65, theta 3 must now be equals to 180 plus 65 degrees. And finally, in our fourth quadrant, okay, so this is theta number 4, with this being 65 degrees. Same basic angle. The last one must be 360 minus 65 degrees, and you get the answer. 4 answers. This is a very important skill because we'll be using it when we solve trigo equations. Okay, Roshini? Okay, so I've got 50 degrees already. Since they say that sine 50 degrees is equal to P, what is the opposite? What would you assign to be the opposite side? This side. P. If this is P, then the hypotenuse must be 1. What if I don't let it be P? Suppose I try to be funny. I let this be 2P. Then what is my hypotenuse now? 2. Do you see how this works? Okay. If I choose to let it be, for example, 3P, then my hypotenuse must be 3. Why does this work? Because of similar triangles. Okay, if this is P, this is P, this is P, this must be 1, 1, and 1. And because they are similar triangles, regardless of whether I'm using this tiny triangle over here, I get the same trigo ratios. Whether I'm using the medium triangle over here, I get the same trigo ratio. Whether I use the big triangle, I still get the same. Therefore, it is easiest to let the hypotenuse be equal to 1 because we are dealing with ratios. So 50 degrees, P1. Since I've got two sides already, this being a right angle triangle, what is the adjacent side? Mentally, tell me the answer. Square root 1 minus p square. Okay, so now we've got our basic triangle already. They want sine 230 degrees. This is in my first quadrant. Where is 230 degrees? First, second, third, or fourth quadrant? Third quadrant, huh? Because first quadrant is up to 180 only. So if I continue over here, this should be my 230 degrees. What is my basic angle here? 50. Yes, it is 50 degrees. If this is also 50 degrees, the basic angles are the same. Do the triangles have the same magnitudes for the same sides? They say magnitudes are same, right? But the signs may be different. So since the magnitudes are the same, I will drop down a perpendicular line over here. What is this side? P or negative P? Okay, what about this side over here? Oh, this side? Along the x-axis, how much is it? Negative square root 1 minus p square. And radius, how much will that be? 1. Therefore, according to this, sine 230 degrees will be equals to sine. What is the formula on the board? Y over r. So what is the y value over here? Negative p over 1. So this gives me negative p. Who is able to follow this example? Raise your hand. I need to know because subsequent ones builds on this. Raise your hand if you really know. Sine 50. So I'll skip part B. And finally, part C. Tangent negative 130. Where is negative 130? Okay, so because it is negative, we are going to go clockwise this time. From here to here, it is 90 degrees, negative 90. Then I want negative 130. So plus another 40 over here. 90 plus 40 will be 130 degrees with a negative. Right? So I get back my third quadrant. It is exactly the same triangle as part A. Because this is 130, then the remaining reference angle must still be 50 degrees. It's the same question. But this time they want tangent. So tangent, negative 130 degrees. So tangent, what is the ratio? Which one over which one? Y over x, what is the y value? Negative p, what is the x value? Okay, simplify to become p over root 1 minus p squared. That's part C. And finally, sine 40 degrees. 40 degrees is over here. Okay, so sine 40 degrees equals to the opposite side, square root 1 minus p squared. Minus p squared over the hypotenuse. So we get square root 1 minus p squared. Okay? Question 17. Slight difference is that cosine of the angle is negative q. So let's see what that negative sign tells us. So cosine 160 equals to negative q. 160, which quadrant is it in? First, second, third, fourth. Practice. So second quadrant. Drop a dotted line down. This is my angle, 160 degrees. Cosine of an angle, which ratio do we get? Which ratio do we get on the board? X over R. Okay, so what do you think is the x value here? If this is 1, then what is your radius? You have to see this as a fraction, which is actually negative q over 1. Okay, compare this with our trigo ratio on the board. X over r, cosine. So what is the unknown over here? Negative q. What is the radius? 1. What is this side? Square root 1 minus q squared. I've got a question. What is the sign of q? Or rather, this q over here, q by itself, is it a positive or negative value number? Q by itself, positive number. Then I put a negative sign in front of the positive number, that makes it a negative number, right? That is why it falls on the left-hand side of the y-axis, because it's a negative x-axis area. Okay, so q itself is a positive number. So now that we have our triangle already, then let me put in the basic angle. How much is the basic angle? 20 degrees. Then let's do part A. Part A, we want cosine 20 degrees. Where is 20 degrees? First, second, third, fourth quadrant. Cosine 20 degrees. Where is this 20 degrees? First quadrant. So over here, this being 20 degrees. So you see that it has the same basic angle, right? As the one in the second quadrant, which tells us that we have the same triangle. But it is we have a congruent triangle. That's a better word. We have a congruent triangle, but it is flipped. It is symmetrical to that in the second quadrant. So what is the value that I should put over here? Q. What is the value over here? 1. And the value here? Square root 1 minus q squared. So if this cosine 20 degrees is simply, cosine is x over r. X value is q. R value is 1. So simply q. Part C. No, part B. Sine 160 degrees. So sine will be y over r. Y value is root 1 minus q squared over 1. So we have square root 1 minus q squared. Part B. Part C. Tangent negative 20 degrees. Brackets here are important. Okay, you cannot just leave it as tangent, no bracket, negative 20 degrees. Must have bracket. So which quadrant is negative 20 degrees in? 4. So draw it. What is the basic angle? 20 degrees. But we are looking for this one, negative 20 degrees. So same thing again, same exercise. What is the radius? 1. What is this side? Negative square root 1 minus q squared. Then the x value is the same. Okay, so tangent negative 20 y over x. What is the y value? Square root 1 minus q squared divided by the x value, which is q. Can we simplify this? Okay, you can leave your answer like this, but I don't like so many negative signs. So I can simplify this to become square root q squared minus 1 over q. They are the same thing. Okay? 70 degrees is here. This is a very common trick that they will have for you. It is not exactly found in the first, second, third, fourth quadrant. It's just found in a right angle triangle. And that right angle triangle is found in the first quadrant. So 70 degrees over here, part D. Cosine 70 degrees adjacent over hypotenuse, so root 1 minus q squared. Part D. Okay, please tell me which quadrants do we have already. Based on this, cosine theta is half. So theta must be in first and fourth quadrant. Then they also tell us that they gave us a range of theta. They say that theta is between 3 pi over 2. What is 3 pi over 2 in degrees? 270 degrees. And 2 pi. So which quadrant is theta actually found in? So theta is in 4th quadrant. Are we working with degrees or radian? Are we working with degrees or radian? Look at this in the question. They say theta between 3 pi over 2 and 2 pi, so it must be a radian question. So find the value of cosine theta minus sine theta, blah blah blah. Okay, let us create our triangle in the correct quadrant. So in the 4th quadrant, here I've got theta. Since cosine theta is half, and this is a trigo ratio, which ratio do we have on the board? Which one over which one? What over what? Come on, quickly. Cosine theta. Which one over which one? Huh? Y? Are you sure? Cosine. Cosine is x over r. Right? So, what is this value here? This is the x value, so it is 1. What is the radius? According to the question, it is 2. So this must be 2. And what is this last side?
2 minus 4 minus 1.
Square root
4 minus
3. You can do it immediately. Now, to answer the question, cosine theta minus sine theta divided by tangent theta plus sine theta. Oh wait, is this root 3 or negative root 3? Almost made a mistake. Yeah. Alright, so cosine theta. According to the question, we already know it's half. According to our diagram, it must also be half. Next, I need to minus sine theta. Based on the diagram, what is sine theta equal to? Negative root 3 over 2. So take note of your substitution. Put a bracket to make it clearer. Divided by tangent theta. How much is tangent? Negative root 3 again over 1 plus sine theta. How much is sine theta? Again, like this. Let's evaluate. Half plus root 3 over 2. 1 plus root 3 over 2 in the numerator. Denominator. Got a negative root 3 over 1. So make that the same denominator. Negative 2 root 3 minus root 3 over 2. Times 2 in both the numerator and the denominator. Leaving us with 1 plus root 3 over negative 3 root 3. Can we leave our answer like that in A maths? So what do we need to do? Times root 3 in both numerator and denominator. So now our answer will be root 3 plus 3 divided by negative 9. So final answer is negative 3 plus root 3 over 9.